For Göran Rydqvist.
So I've been asked to talk to this crowd today. Trouble is I'm a programmer, right? So I can't talk. I just program. My name is Göran Rydqvist. I co-founded this company in 1990. I actually started hacking on the original Configura code in 1989. First prototype was in AutoCAD. I brought a few relics fit for the museum. This is my first programming book, 6502 Game Programming. You really should take a look in this. And this is for the really advanced stuff. Basic. That was from it was Apple II, yeah. I was doing that on the ABC80 before that, a Swedish computer. It's really advanced. So 10 print Olle Andersson. 20 print telephone number list. I highly recommend it. This is code dated 1992. It's a backup copy of Configura. There might have been another bin in there. If you're curious, you should come and take a look at it, because I'm surprised when I see this code. Because I know I have developed a little since we started. It's 30 years now. My skills have developed a little bit, but this actually looks very clean. So there was a fundamental philosophy that was there already from the start, and we've been keeping with that all this time. So where do I come from? D84, so computer technology at the university here in Linköping, 1984. I stayed on as a PhD student, and at the end of that, I began thinking about this, what became this company. During the time, I also spent 6 months at Xerox Palo Alto Research Center in Silicon Valley. It's just by Stanford, so nice place. All right. So what is PGC? I don't know how many times I had this. PGC is really a very stupid nothing. It means you sit down in front of the computer and you try out a piece of software without any prior knowledge. And whatever annoys you, you should fix. You get it? You know, when I sit down and I have to press the right button, I get annoyed. Why can't I do this in a more convenient way? Why can't the computer understand the gestures I'm doing? So if you stand behind a user, when he uses your piece of code, take a look at what he tries and the way he approaches the software and the way he tries to get an understanding of it. That is what creates PGC. So it's really from the start a number of very small and simple ideas, but we combine them all together, we get this very powerful user interface. And I really hope that you dig into this idea, because that is what makes CET and Configura different from other software out there. So, we've done a little programming language stuff here. Why did we do that? Johan and I sat in, we started on these Spark stations, Sun Spark stations. It was like 16 megahertz 32-bit computer with real Unix. So it was a real computer. The PC at the time was a toy running only DOS. You know, no memory protection, nothing that you're used to, no real graphics. No Windows, for that matter. We had these Spark stations over there. Around 91, 92, we had, I think the turnaround time for adding a print in your code was between 30 and 60 seconds. And we were highly annoyed, because both of us are highly impatient people. We don't like to wait. So what is a programmer? In most situations in the world today. I got a kid coming in and worked here for 6 months, and he was at Saab before, and he said that he was working on, they had a programming language there for programming missiles, I think. And the turnaround time was 50 to 55 minutes, and there was a ton of manual build steps as well. Wonderful, huh? So what is a programmer in that context? He's a highly skilled, highly paid professional that waits for computers. Very, very efficient. So we didn't want to do that. We were long in 91, 92, our conversation was we want an incremental programming language like Lisp or BASIC or whatever, but we need the speed of C. We can't have a slow interpreter. It won't work. So we started doing all sorts of various experiments, trying to make very efficient interpreters. For example, that was the Z switch-based interpreter, and then I did a threaded. There's an extension in GNU C which enables you to switch jump on an address. So your code becomes just jump, 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 and jump back. So it's a highly efficient interpreter, still way too slow. So the last one before CM and CVM was F1, where I tried to use the JVM backend at the time, so Java Virtual Machine. It wouldn't do incremental, so if I changed one class and another class used it, I had to reload both of them into it, and I thought this will not work for a bigger system. So I actually had a version of a compiler on top of JVM doing my own programming language compilation down to JVM code. But no, I threw it away. And then we started on what we're doing today, that you're all familiar with. So let's go on. Again, this philosophical question: why do we program computers? What's the point? No one? You're all programmers, aren't you?
To help people.
To help people. That's a good one.
To make businesses more efficient.
Yeah, efficiency. So automation, if you boil it down, right? So in a sense, a computer is a robot without legs. So what's the definition of a robot in Hitchhiker's Guide to the Galaxy? There are a couple of them. There's a plastic pal that's fun to be with, right? That's Marvin. But if you take the non-marketing version, it's a machine that's meant to do the work of man. If it's meant to do the work of man, it's automating things that we otherwise manually have to do. So now we have a robot without legs, and it should automate our work. We should not adapt to the computer, right? This is fundamentally the most important thing I can teach you. So that means when you make a program or when you're working with a computer, you should adapt the computer to fit you and to fit the users, not the other way around. So, what do we really do? Lump of code. I had about half an hour of preparation, but I did this lecture for the university. So, yeah. So when we're hacking something together, I mean, it's not much of an engineering, is it? It's more like a dark art of magic, and there are different magic users, right? They have different spells. They like different patterns. One like reactive programming, another one like imperative standard programming or object-oriented or whatever. So somehow you get it to work. Do you understand the code? If it's more than 10 lines. Do you even understand 10 lines? I don't. So it's really a lot of some subconscious and strange stuff going on. So what yeah, let's just go on. When we create any type of program with the regular tools that we're used to, like functions or function names, method names, you have a couple over here. There is a device begin paint up there. And then there are some draw lines, and there's an end paint down there. And I added a little dragon there on the end paint, because don't forget it, or there will be dragons, right? The system will crash because you're leaking. So, but when you created the device dot begin end, etc., you are creating what? Creating a couple of functions. Yes, but you're also implying a syntax, because there's no way to express the syntax with the regular programming language. It's implied with these words. And then you have to tell every programmer that will ever use this device thing that if you type the begin thing, you always have to have the end there, right? Otherwise it will go to crap. So why don't we make a proper programming language instead, so we could abstract this up? So this is all leading up to that. It's also interesting to just consider software development in general, because it is fundamentally an unbounded additive process. Don't you agree? Why is it unbounded? Why aren't we just doing... Oh, my grandmother actually asked me, I think like 8 years into Configura, aren't you finished with that program? It's very cute, right? We're not yet finished. It's unbounded. One of the most important properties of our minds is that we can forever zoom into smaller details. And there's no end to that. And there's also the other dimension of just adding more modules, more functions. But for every function, we can also refine and refine and refine it. And every time we refine it, it improves, and we will find a smaller fault, and that fault will stand out as the most important, and that has to be fixed right now. Go into hi-fi if you don't know this, and you will switch cables. So we fundamentally create programs through language. I don't think we really create it through language. The thinking is more mysterious than that, but we formulate it through language, right? That's programming language. So precise, consistent, and orthogonal is the keywords here. If you don't have precise names or meanings of everything, it will not be good. If it's orthogonal, that means they're not overlapping, so you can combine them in various ways and get new results, and it will work in expected ways, right? And consistent, yeah, it hangs together the way it should. So I'm building up to language as an abstraction in a programming language is the most powerful thing that we can provide a programmer with. Basically, this is part of geometry function, and it's not all that great. You see, if we look at how can we even guarantee that we tested all the branches, etc. But this is typical code. It's a lot of it out there. So I would not recommend us to create code like this. I would refactor it, take out pieces of it, name it. Because now it's just one big blob of things. And maybe this is useful for something else. But it's embedded inside this function, so it can't be reused, right? It is embedded. It can only be used in that context. So a programming value change is, you're making very low value down here, and you're making high value up there. But that also means the most powerful mechanism, which is designing language, is also the most difficult one. So everyone should not do it. Do you know what happened to Lisp? I mean, Lisp has been around since like the 50s. It's still pretty much the same because it's an ingenious language. It has the full ability to change its language. You can hook into everything, change the reader of the. It's ingenious. It's super. It should be. It must be the language of the gods, right? I have the slide later. But it seems like it ended up in a death that was caused by every programmer changed the language. So you could more or less not read a single program in Lisp without, you have to go through all of the code to find all the macros that changes all the meanings. So it's not really even the same semantics in the fundamental part of the system. So you don't even know if a function call is a function call. So you see what I mean? It gets very difficult to communicate or even combine. How can you use an external library if it's not built on the same style, conventions, and semantics, etc.? So it still lives, but it lives very, very small, Lisp. So I don't think there is a fundamental problem with us providing a feature that allows us to create language. It would be a blessing compared to what templates in C++. That's another programming style, right? But we have to use it with smarts. So we have to be very careful. The more powerful the thing that we're using in the programming language, the more important it is that we use it the right way. So even if we go prop-ob and go dynamic, or we use the new X API, if we use it the wrong way, it's just going to go crap. You really use it only when it's required. If I introduce interfaces, it's basically multiple inheritance. There's just new cute names for it. It requires the same thing inside the compiler as any multiple inheritance system. If I do that, and there are real cases where you really need it, but it tends to get overused in all sorts of situations, and it gets a terrible spaghetti. So that's sort of why we have not yet provided it. It might come in the future version. So here is the Lisp thing. I'll skip that today. So why are things like they are in CM? Why don't we type while like they do in C++? Oh, they type for in C++. That slide is wrong. I remember there was something wrong with it. The top one says for in C++, right? And in CM it says while. I call it the conceptual slide because for comes fundamentally from logic, for each x belonging, or set theory, for each x belonging to, and then you make a constraint condition and you have enumerated some domain. So that's for me, the history of for. So for should be something that for x that belongs to. That's why I use the in word in the for syntax. So conceptual slide is not all that's great. And why when you create a new language would you carry the syntax of C from 1970s, where you have to remember to type the break and the default is just a plain fall through. So all those two are reversed. So semicolon ends, or the statement ends the case in CM, and the default is you have to explicitly say I'm going to fall through, otherwise you're going to get a bug. So there's a bunch of this going on. What's the most important statement that you will ever use? The most number of times, it's 100 times more than anything else, it's a print. Because you don't know what you're doing, so you have to find out what you're doing. So we shortened that out to PLN. I've been thinking about other changes to the PLN syntax, but I haven't really come up with any. Doesn't anyone else have any good ideas of what we could have? Like the hash syntax, A equals, and the value of A. Isn't that a fantastic little addition? I use it all the time. I really like the more convenient way to get colors than calling a function, but it's pretty convenient because I use this EB blue, for example. So Emax, bold, blue, all the time to distinguish one print from one section of the code from another, for example. I think we step into this. The 7 golden rules of programming. I wrote this a long time ago. So we're not going to read the small print, we're just going to read the title. And this is more of a discussion thing. So I changed, this is the only one I changed in all these years. Stay incremental at all times. So it comes back to the beginning of this talk, right? Stay incremental means that we all never wait on the computer, or as far as it is ever possible. So why do we have to iterate? We already have this incremental programming language. Well, a lot of programmers tend to build this create step, and then you publish, and you load, and then you run. And when the database grows big, this goes up to minutes. So you created a non-incremental system on top of an incremental system, and you're dead again. You're dead in the water and just sitting there and waiting for these publishing steps. I mean, if you sit there and click in a UI like catalog creator, or if you're programming code, there's no fundamental difference. You have to make a change. You have to do the full cycle until you can test the thing. Until there, you don't know. So it's fundamentally programming. It's just another programming language with a lot less expressive power and flexibility. So stay incremental, and don't forget that. That also means for everything you do, your daily activity, when you're sitting there and I'm just going to fix this bug, but I have to step there, click there, do this, automate the test cycle, give it a statement at the end of your file where you do most of your editing, so you can Control-Alt-P and do the complete thing. This is staying incremental as well. So it's the mindset of doing a fully automatic turnaround. Just going to do a few repeats. It usually ends up with 100, right? Am I wrong? It takes 100 times before you really understand, before you really grok what's going on. So this is really important as well. Straightest possible path to the goal. It can be misread as write ugly, dirty code. Yeah, if you can do that and get to the goal, fine, but I can't, so I don't. I refactor very quickly. I very quickly refine and refactor the code because I think it gets me to the goal quicker. I don't like debugging. I like to refine the code instead. So the best debugging is not debugging at all, period. But anyway, you can get to the goal, because before you're at the goal, for example, the snapper that's going to snap or whatever, you make this snapper do something else, some gesture interpretation. Before you're there, you don't know if it's a good idea or not. You have to test it out by feel. PGC is feel. In the end, how does it feel when I use this? No, it's all crap. With all these situations of, before snapping became what it is that you know today, in the beginning we were messing around with all these styles. So you came in and it snapped, and you moved just one pixel with the mouse and it snapped out. It popped out to the cursor again. So it wasn't stable, it was popping in and out like this. That's a very typical thing of, oh, it felt like a good idea to base it on this situation, but when you saw it in reality, it was crap. So just redo it again. It's really interesting when you're going through from one of these styles that doesn't work, and you say, oh, if I go there, it's always greener on the other side, right? Then it's going to be great. And you go there, it's going, no, that's crap. Maybe if I go there, it's going to get good. And you're toggling. So you're toggling between two bad ideas, and they don't work, either one of them. It happened a couple of times. So shortcuts to the goal, that means cut away everything that's not required right now, just to get up and get a feel, and then go back and refine it until it is the highest possible quality. Solve the real problem. Yeah, this is hard. The previous one is part of this. You can't know if you're solving the real problem unless you get something out there. Sometimes you have to get it all the way to the user so they can try it out. So if you're going to design this new supermodel that you know is so fantastic, and you're sitting there for 3 years in your chamber, and it comes out, and no, I don't want that, I want that. So it's all shooting on the side. So this is total misuse of time. Write beautiful code. So code has to, I often get in conflict with academics because they tend to advocate commenting, and I don't really like commenting. Do you know why? Gets old. It gets old fast. I don't know if it has 3 weeks. It's more like milk. It gets sour very quickly, and then it's worse. So you get into this piece of code. Maybe I wrote it or someone else, and I read this comment, and I look at the code. Look at the comment, look at the code. The comment has nothing whatsoever to do with the current situation. And it might explain some complex relationship between different things in this situation. So what do we need the code for, or the comment? The comment is more or less an obfuscation or even misinformation, intentionally created to derail my mind from what I need to know about this. So there's only one way that will work, and that's making the program as easy to read as possible. That will be maintained, because that is what is running. That will be kept alive, and that is what makes you understand the code. And then, of course, you can use strange patterns or not, etc. So there's a lot of into this design that goes into making the code understandable and readable. But beautiful comes from the idea that you should be able to actually even to put the code up on a wall, and then look at it from a distance. Does it look good or not? Develop your basic programming skills to the extreme. I was watching this video of these two violinists playing the other day, and one of them, both were amazing. And then they had these pieces where one played and the other looked, and then they reversed and changed. And this guy comes up and he starts playing with all 10 fingers at the same time, and he makes music. It just looks like magic. It's a level of attachment or interface to his violin that's unbelievable. But both had it, They're great musicians. So if we're programming and it's a black art, can we get away with bad typing skills? No. We have to be really good at typing and Emacs. That's our primary tools. I don't know anything else than Emacs that allows you to work that fast. That is required. So there shouldn't be any trouble in refactoring 1,000 lines of code. It should be done in 10 minutes, 5 minutes, 3 minutes. Just model it, change it around, turn it around, query replace, move this to that, make it look better. No, that didn't work well. Keep working on it. So it's like a piece of clay that you're modeling out until it's good. And if you're not good enough with your fingers, it's not going to happen. Then it's difficult, slow, troublesome. So this is really an important point. Surprise your boss. That means don't just take, you get, someone decides we should fix this problem, then try to make it better at the same time, not just make the minimal fix. Or we'll make a patchwork out of the software. We very easily make a patchwork by just looking in Jira, fixing the specific ticket. It's a high risk also that we make bugs, side bugs that comes from this. So it's not a good idea at all. Take care of your health. You know how many seconds a brain cell will function without oxygen and sugar? It's about 7-8 seconds. If you don't believe me, come up and I'll strangle you. We'll see how long you can take it. Isn't that great? I mean, a muscle cell has like 20 minutes, 30 minutes before you can just staunch it up here and it will still live, you know. And the nerve extensions, they will live, but not the nerve cells themselves. They're really highly developed and highly sensitive and highly active. We also need to rest. So how do you rest from something that's so intensive that your brain thinks it's a survival when you focus so much on something? Haven't you noticed? You focus so much that you go into, like, we have to solve this or we die. That's basically what we do every day. So if you take this home, your brain is going to churn on with this, and you're going to, risk going into the wall, burnout. That's the highest risk of this occupation, I think. So what you require is detachment. You have to detach yourself from that thinking. But you know what happens when you do that? If you're really good at, really detaching means you have to do something completely different, like go and do sports for a full hour. When you get out of there, you should be empty in your mind. There should not be a single thought about work. But then the real work happens in your mind, because then the holistic thing starts happening. So the next day, when you come back to work, something has happened already, and you can make much better solutions out of the code than you could by just trying harder, and trying to apply logic and standard thinking. So that is absolutely required to do anything at any high level, and it's also very, very good for our health. So I highly recommend it. So, any questions? I would like this to be a little bit more interactive. I wasn't really planning to do all that PowerPointing. Any questions? Anything you would like to talk about? Let's not talk about how you make a snapper. That's for the other sessions. So more philosophically, why is CM the way it is? Why do I program the way I do? How do I approach something specific? Or you want to see me do push-ups? I can do that too.
So I wanted to say I didn't really for a while understand the lack of commenting in CM, but now that you explained it that way, I say that it makes a lot more sense.
Yeah.
Right? Because I write a lot of code in CM and C# and all these other languages. A lot of times the comments, most of the time, are out of date.
Yeah.
So they don't make any sense. They confuse you more. It makes it more difficult to read.
What's this? I'll actually will show you that I'm lying. I changed my style a little. So I'm trying. When I said something out, this is Xclip. Xclip has grown into. It's not a small project anymore. It used to be just this little renderer that can render in a polygon something else that this is in other space. So it's basically a viewport. I'm starting to try to summarize some type of conceptual overview in a README that I put in the same directory. But it's really hard to keep up to date. Yeah. And as soon as the requirement change anything, you have to be obliged to go back and fix this, or it will.
It's hard to remember as a programmer. You're not programmer.
Yes, exactly. And then you're going to sit here and sit there and evaluate every line that you wrote. Xlib is printed through GDI view, etc. Is still true? Yeah, that one probably is. But you know, every statement in this file has to be really carefully monitored, or it's crap. And you do know that we have interface comments, so we try to comment our interfaces, but we don't spend like yeah. No, the philosophy is fix the language instead of fixing it through comments. There is an old joke. I think it was from a very early Byte. Byte magazine was these big pieces of computer magazines that came out once a month in the 80s. So there was this article about the future AI compiler. You know what it would do? Of course, it knows that you only create bugs, so it would read your comments and compile that instead. I wonder what kind of code would come out. There was an early compiler, one of these. Oh, I forgot what the name was, but you could actually write a piece of Shakespeare to it, and it would create a program. The reason for it, so it would try syntax and try to fix the syntax in every possible way until it got a working program. Even if you just inputted nonsense into it, it would create a program. Because the situation was that it took a full 24 hours turnaround to get the program to run, because you had to punch cards, insert them into a batch queue, and then get the result the next day. So even if the result wasn't perfect, sometimes you could match how the compiler changed the program to a result that still would be useful. It's a little different today, right? Yeah, good question, by the way.
I had a neat idea as well, if you wanted to talk about it. But what if, for example, if you built into the compiler a way to have the comments expire after a certain period of time, and it will change color and say this comment is like 6 months old?
It's highly interesting, but I'm not sure if it's a compiler or Emacs or Git or what it is.
Yeah, I don't know how you.
But I've been thinking about exactly that, so it will fade out.
Find a way to do that.
Or maybe go towards red. It's less and less informative. What was the oldest cut is out that we had? 2000?
It was from the 90s.
90s, yes. Good, eh? Look, that's also another reason to comment, of course. Yeah, question?
How do you approach old, non-beautiful code? Do you like rewrite it, or do you just...
Yeah, I can't even read it without changing it. So my own style of trying to understand some piece of code, which I get into, is start to change it. I might very well throw the changes away. It depends on why I'm doing the changes, but I have I can't just sit and read from start to end. It's not, my mind doesn't work that way.
Do you think us as an organization should do that? I mean, I think it's bug prone to refactor all the time. How do you think we should approach it? Because I agree.
You shouldn't refactor all the time. You shouldn't refactor when you're fixing a critical bug in release, in the release cycle. But at all other times, I think you should refactor all the time. I mean, when you're in your regular project. So, and I don't think it's bug prone. I think it's bug eradicating. You combine refactoring with test suites, then you very quickly. You can do a refactor which you feel is 100% safe, and you have a test suite and it catches an error, and then you have to rethink. And that's really an amazing teaching tool to make yourself understand the little edge cases that might be in there. But then you have to put in the work and do the test suite, otherwise it won't work. So and of course it's much harder for UI-based things to do test suites, but many times you can test fundamental functionality, like bring a snapper in, click on this quick prop. I mean, set this property, and then you check that something else has happened, and you just verify that very simple fact, and you remove it, and you make sure that both got removed with the test suite. Then you have a little test cycle, and you can test very fundamental things, but you're going to have a repeated test that you can run forever after that. And very quickly you start getting new ideas of these little tests that you can keep adding to it, and so you get a baseline test that just can be run all the time. It's highly efficient. Mm-hmm. More?
I could describe a pain point that I have with that. So much of what we're doing is, user experience, trying to streamline user behavior, and it's very difficult to write test scripts for that.
Yeah.
Right. We can unit test methods in a class or whatnot, but actually testing whether or not dragging the cursor this way behaves well is kind of difficult.
And there are so many aspects to it. Even responsiveness, time is important. And time is difficult to, you might change something and it doesn't look dangerous, but it will change the timing of things and make it sluggish or slow, and then the user experience suffers. But it's usually simpler than that. So I think we have so much backlog of user experience. So do you use the software? Do you draw with it? If you don't, you have to start. Otherwise, how can you have any idea what you're doing? It's like building a car or designing engines for cars and never driving in a car. It's ridiculous if you think about it. You have to sit down and try to design something. That's the only way to get a feel for what the software actually do. You have to use it. Imagine you're a dealer and you want to make an office layout, and then sit down and do an office layout. Spend some time with this. We'll take the draw tools and sit there and draw for a while and see what annoys you. That really is the only way. There's no manual. We can't sit down and write a PGC manual. It has to work this and that and that and this. And there should be invention. This fundamental idea of automating and making it easy and gesture-based should create invention in the long run. But I'm not really seeing this, and I'm frustrated. I'm wondering why it doesn't happen. We're a big organization. We're a lot of developers. There are external developers as well. Doesn't anyone want to do that? Oh, customer doesn't want to pay for it. Do they even know they can get it? Are we so bad programmers that we can barely make a function happen? So we just get our nose over the waterline and can breathe a little, and then we're sinking again? Is that programming? So this comes back to the golden principle. We have to develop our skills to the point where we can model with the code. So if we have 8 weeks of project times to make a feature, then in 2 weeks we have to have something we can test out. Otherwise there will never be PGC, right? If we barely make it to 8 weeks to get anything to work and it's a little buggy at that time, it's not going to be PGC for sure. So our own efficiency has to be higher, and we have to use each other's knowledge. The new thing I'm trying to create with this architect-based organization and RRT is to create development time and communication, so we can spread this knowledge and reuse all the experience that exists at Configura. Mm-hmm. Anything else? Shall we hack something? I don't know. I didn't really expect this crowd. I wrote this just a couple of days back, and it's just a skeleton because I gave it away. Let's just take a quick look at it. There's been some discussions about reactiveness and not. And if you think about it, object-oriented programming is usually reactive. So, because you're sitting there in your method, maybe it's an example is in Xclip. There is a source snapper and there is a wormhole snapper. The wormhole is the viewport itself, where it shows what is cut out from the main space. So then you're in unsuspended. So someone probably pressed undo, the ControlC. So we're in unsuspended. And we react to unsuspended, so we have to start up the clipping renderer, for example. We have to initialize things, go and get the scale from the source. Crash. Source doesn't exist 50% of the time. There's probably a hash table in the background. So if we're just reactive and looking locally at it, it looks right to just do the access through source. It works all the other times in all other situations. It's a very safe access to do. But in this situation, the source has not yet been unsuspended. So just doing it reactive can be kind of bad. And what else? There is a high risk that we call something that calls us back, and we're recursively, more or less, going recursive on this. So So when you do that, immediately you don't really have any feel for the number of times it's going to be done in the span of the event loop either. Right? So someone else might also call this situation and do the same things over and over again. And even if you don't call unsuspended, you might call something that gets other things done that was done by unsuspended. So we lose control over time, right? So this thing that looks very simple and easy from the start, it suddenly becomes a time monster because it cascades and cascades again. So the basic remedy for that is just using validations. Simple invalidation flag. So instead of doing it now, do it later. And this is a much simpler example. We want to track the visible viewers of a space. So I wrote this little micro thing. This is a very quick sketch. There's an invalid flag. There are the current visible sequence. It's taken from a set, so the sequence is faster. So if we're asking for visible wormhole snappers, then it looks at invalid, and if it's invalid, it updates, and then it returns visible. So then this way is lazily delaying the actual computation that's required to know this fact until the time when you ask for it. So if you never ask for it, you never need to spend the time. If you're reactive and just doing it now, it's going to happen immediately, right? So yeah, you can't say for sure that this would be a good time, but then we know that it's probably not going to be more than a couple of hundred in the worst possible cases. And the test for visible is actually super fast. It's a sequence or a set any question. So it's checking count equals 0. So we don't worry about time. This is probably a microsecond to recompute, to do the update. So you see, there's a number of things going on here. I'm trying to minimize the delays for the critical path. I'm also trying to consider what happens if there are 10,000 viewers going into the system instead of the regular test case, which is 1 or 2. 1 or 2 is not hard to get quick, right? But if it really is 10,000, yeah, that's why I'm going through visible as well. I don't want to compute this thing that I'm going to use this for on all 10,000 that are not visible right now. If you can't see them, why should you compute something for them? So that's why I want to determine the specific fact as well. So just an example from recent reality. Do you use ControlC R? Or just read me. Say I'm working here in Snapper 2D. I want to do rebuild, but maybe I also want to render. Maybe I have some test code in here in stencil renderer, StencilBuffer renderer. So I do ControlC R and Control Y. And now I can Control Alt P, and it will run that file as well. We have a bunch of these things that are there so we can cut down the cycle, right? So we can stay incremental at all times. So write up your test code. Do you ever use seam runtime reflections? Do you know how easy it is? For G in globals or for C in classes? Find for F in C.fields. If you get a field that matches, so you take the field.name, match the name towards something you're looking for, and you take f.source.error prefix, and you can next error to that if you plan it. So you can search through the whole database of your program and make specific matches and just next error to whatever matches you need, for example. So that's one way of making a tool. Another way is, of course, to make a UI like the inspector. But why settle with the inspector? Why don't make your own? It's not hard. It's really fast to do your own tools if you need them. So don't get into this mindset where because we're used to a monopoly on the build tools and the programming language tools, but now there's not a real monopoly. Yeah, there's a little monopoly for changing the compiler for real, but there is so much that you can do outside of the compiler. And that means we can build our own programming or debugging tools as well that are specific to the task we're trying to do. And there are 100 different debug methodologies that I know and I can apply. They're all, my style is very basic. It's mostly fencing. Fencing means cutting out the big parts of the system so I get a smaller area, a small area of suspicion. But there are very various ways of approaching the fencing, depending on if you're looking for a resource leak or if you're looking for a crash or whatever you're looking for. I mean, the basic crash is so easy. It points there, it just makes error, right? But if the crash is not really related to the cause, you have to fence the problem in through a repeat. So don't hesitate to ask if this ever occurs. You get into a hard debug scenario, then I probably can help you work faster. All right. So, thank you.